So very last section for the test 2 is section 8.1. Okay, so section 8.1 is basically the review of the chapter 5. Okay, there are different ways of finding the integrals, and chapter 7. Okay, so there is no new formula, just the formula that we used before. Okay, do you remember that formula? So you see that these are the formula that is given on the very first page of your book. Okay, you see that if there is an integral of 1, then it is u plus c with respect to u, right? A to the u is that, e to the u is e to the u plus c, right? If there is u to the n, it is u to the n plus 1 over n plus 1, right? Plus c. And then a to the u is that, and the sine u has negative cosine u, and so on. Okay, so these are the formula. You can use directly this formula, or you can do the long way, meaning that a substitution method or whatever method you know. Okay, so let us do the first problem here. So it has 5 over t plus 6 to the third. Okay, so you can use the formula directly, like we have a formula. The formula is this: if there is like integral of ax plus b to the n, then the formula is ax plus b to the n plus 1 over a times n plus 1 plus c. You can use that formula directly, or if you want to, you can set t plus 6 equals to u. Okay, so you can do that way too. So if you do t plus 6 equals to u, then dt will be equals to du, so that dt will be replaced by du, right? So you will write that integral is equals to, you can write 5 dt over u to the 3, right? So how do I find out the integral of this? Let me write down here equals to, let me write down 5 outside the integral, and then move that u to the q as u to the negative 3 du. By the way, this would be du because that dt is replaced by du. Okay, so what do you get? That integral is 5 u to the negative 3 plus 1 over negative 3 plus 1 plus c, right? So that will implies 5 u to the negative 2 over negative 2, right? That is the final answer is not the final, but we will have to substitute back to the t. So negative 5 half, okay, and then u to the negative 2, right? If you move that to the bottom, let me move that to the bottom on this step, okay, and then u square, you will get 5 over 2u square, right? When you plug in back the value of u, you will get negative 5 over 2u is t plus 6 to the 2, and then plus c. That's what you get. You see that? But if you use that directly, how would that be? It will be moved to the numerator, right? It will be like this. It will be like 5 integral of t plus 6 to the negative 3 dt, right? And if you use that formula, then you will get t plus 6 to the negative 3 plus 1. That will be negative 2. Divide by a is 1, and then n plus 1 will be negative 2, right? So you will get 5 over negative 2, and then t plus 6 to the square. That's what you will get directly if you wanted to use that. Okay, all right, so the next one is that one. So again, we'll do u substitution here. So set t4 plus 1 equals to u. Then what happens if you find the derivative? Then you will get 4t cubed dt equals to du, right? So what is t cubed dt then? That will be 1 over 4 du. Okay, let us denote that as integral I. Okay, that as integral I. So therefore I equals to here, and therefore I equals to, what do you get? I equals to, let me use different color there. So I equals to, I'm writing t cubed dt. That t cubed and dt becomes 1/4 du, right? 1/4 du. And then that is root u, right? So what do you get? You get 1/4 integral t to the 1, u to the 1/2. So u to the 1/2, okay. u to the 1/2, and then du. So what is the integral of that? That is 1/4 u to the 1/2 plus 1 over 1/2 plus 1. That's the power rule, right? That is 1 over 4 u to the 3/2 divided by 3/2, right? What is 4 times 3/2? Because there is 4 times 3/2 in the denominator. That will be 6, right? So that will be 6 because 2 divided by 2 and 4, that will be 3 times 2, right? So the final answer is 1 over 6. U is, what is u? T to the 4th plus 1 to the 3 over 2 plus c. That will be integral I equals, because we assume that I, that value is that one. That's what you get it. Did you get that? Alright. Alright, next problem is question number 24. This problem can be done in so many different ways. But if you want to use U substitution, okay, if you want to use U substitution, you can do it. But there is a shorter trick as well. So for the U substitution, you will be doing set U equals to x plus 4, right? Then what do you get? Du will be dx. So that dx will be replaced by du. And x plus 4 will be u. Now we need to replace that. Let me denote that by I. So what will be I then? I will be, let me pull that 3 out. So if u is x plus 4, then what is x? X will be u minus 4, right? You can write, if you pull 3 out, what is left is x. X is same as u minus 4. Because when you substitute u, you want to change all the x in terms of u, okay? And then du. You see that? So that will be 3 u over u minus 4 over u du. What is u over u? That is 1, right? So what is the integral of 1? It's just u. So 3 u and minus, what is integral of 4 over u? It is like 4 times natural log of u. You see that? And then that's all, and then plus c will be there, right? But what is u though? U will be 3x plus 4 minus 4 times x plus, ln x plus 4, right? 4 times ln x plus 4, and then there is a, let me write down bracket, because this 3 is multiplied to each of those, plus c. That's one way. But you know what? You could do slightly different like this. You could do the alternative, okay? You can do this way, or you could do like this. You can write like 3 outside, and then you could write what is left if you pull that 3 outside the integral is x. So you can write x plus 4 minus 4 divided by x plus 4, right? And then you set x plus 4 over x plus 4 will be 1. So the integral of 1 is x, right? And then minus 4 over x plus 4. You will get negative 4 over x plus 4. That will have integral 4 natural log of x plus 4, right? So if you do that way, you will get just x minus that thing. But that plus 4, no worries about that plus 4. That you can just merge with c, okay, and then write that answer. That is perfectly fine. The next problem is question number 35. Again, that question number 35 can be done 2 different ways. So let me do just U substitution first. I mean, you will have to do U substitution either way, right? So what I'm going to do is, you know that the property of log says that if there is exponent, you can pull that to the front, right? So you can write this as, let me write down like 2 an integral and ln x over x dx. Okay. Now I want to do U substitution. How do I do that? Which one should be u? Natural log of x, right? Because the derivative will be 1 over x dx. So set natural log of x equals to u. Find out the derivative. 1 over x dx will be du. You see that? So therefore that integral I will be I is equals to, you can write 2 and then integral u times du. Did you see that? Because that natural log of x is u, and 1 over x dx will be du. That's what you get. So what is the integral of that? U square over 2 plus c, right? That you cancel that 2 and 2. So what do you get? U square plus c. What is u though? U is natural log of x plus square, right? Natural log of x square plus c. So one of the very important thing that you should notice here is, if you have, let's say, if you have natural log of x square, that x square is for x only. That square is for x only. In that case, you can write that 2 natural log of x. Okay, but But if you have natural log of x square, you cannot write 2 natural log of x. Why? Because this is natural log of x times natural log of x. Okay, natural log of x times natural log of x. But this one is natural log of x times x, right? They are different things. That's why you should be careful on that. Okay, these two are not equal, but these two are. Alright guys, so the next problem I want to do is question number 39 from the book. Okay, so on question number 39, you see that you have -1 over under the root 1 minus 40 plus 1 square. Okay, so do you remember that if there is a negative sign there, then the integral of, and you see that on under the root there is 1 minus u square format, right? 1 minus u square format. So how much would that be? Let me get the formula first. The formula here is, so derivative formula, what I'm going to show you here is, so let us see that. You see that the inverse function formula, you see what is the derivative of sine inverse is 1 over root under 1 minus x square, right? And if there is like derivative of sine inverse u, there is 1 over 1 minus u square times du over dx. You see that? Now, so what does it mean is, if you have and similarly for the cosine it will be minus, right? So let me write down the formula first. Okay, if you have, let's say, 1 over 1 minus u square times u prime, okay, dx or dt, whatever, then the integral of that is cosine in, if there is minus, okay, if there is minus, cosine, if there is plus, there will be sine, cosine inverse u plus c. That is the formula. Okay, now isn't this like -1 over 1 minus u square, that is like u, but what is not given there is u prime. What is the u prime? If you set that as u, the u prime will be 4, right? So we need 4 here, not just 1, we need 4. So you can write this as, basically you can write this as, you can write this as integral -1 over 1 minus 40 plus 1 square, that is like u square, right, times u prime is 4, but you cannot just add 4, you need to do 1/4 there to balance that, right? To balance, because we're writing equals to, that equals to, okay, and then dt. So this will be cosine inverse, u is 4t plus 1, there is 1/4 though, right, and then plus c. You can do this way, or you can pull that -1 out and then do sine inverse. That is perfectly fine, okay, if you want to do in the format of sine inverse. Okay guys, so the very last problem that I want to do is on this video, and I'll do a couple more examples in the next video as well, is question number 45. Okay, on question number 45 we have 4x squared plus 4x plus 65 there, right? So how do you do that? Is what I'm planning to do is I want to take 4 out from the first and second term. Okay, let us try that. So 4 is there already. Let me pull that 4 out, no problem. Okay, what I'm going to do is 1 over 4x squared plus x, and then there is plus 65 outside that parenthesis, and then dx. You see that? Now I want to complete the square inside that parenthesis. How do I do that? Is there is 4 integral 1 over 4. So do you know how to complete the square? You need x squared plus, so what do you need? You need, there is x already, okay, and then plus, what I'm going to do here is, what is the half of that? It is like b ax squared plus bx plus c, right? There is no c, but we have ax squared plus bx, right? So to do that, first of all, we need to write down like x squared plus something x format, right? And then half of that, it is like 1/2, and square of 1/2 is 1/4. You can do that, right? And then, so you just added that, okay, you added that, but that's not equal to that one, but we are writing here equal. So what do you get? You get 4 times x squared is 4x squared. 4 times x is 4x, right? 4 times 1/4 is how much? 1, right? That's the extra thing. So I'm doing -1 there, and then plus 65. Why did I do -1? Just to balance the previous step. I'm just doing plus 1/4. Why didn't I do 1/2 or 1 or 2 like that? Because I want to complete the square. You will see that, okay? So you get basically 4 and then 1 over 4. How much is that? You can just complete the square at x plus 1/2 square plus 65 minus 1 is 64. Does that make sense? That's what you get here. Okay guys, alright. From these steps, there are 2 different ways to do that. One way is just take 4 out and then use a square plus u square format. Okay, the other way is just write integral of 1 plus u square format. Okay, now let us look at that. So how do I do this? Let us take 64 out. You will get 4 over 64 integral. That will be 4 over 64 here as well. So that will be 1 over 16 and then x plus 1/2 square and then plus 1 dx here as well, right? So what do you get? You can write 1 over 16 integral 1 over 1 plus x plus 1/2 over 4 square. That 16, I'm moving this inside and writing 4 square. That is 1/2, right? Now what is the formula? Do you remember the formula? The formula is, what is the derivative of tangent inverse u? The derivative of tangent inverse u is 1 over 1 plus u square times du over dx. So the integral of that right side will be tangent inverse u. Okay, integral of the right side is tangent inverse u. So there is dx. So what is the derivative dx? What is the u? So this guy is basically u, right? That guy is basically u. Okay, so this guy is basically u. So what is the derivative of u? That is, what is the derivative of u? That is 1/4 will be the derivative of u. Basically we need 1/4 on the top to write the tangent inverse that thing, right? So let us do that. 1/4 there, and then there are also 1 over 1/4. So let's do 4. 4 times 1/4. Basically that will be 1, right? So what do you get there then? So you will get, so divide that. So is it 1/4 integral 1/4 divided by 1 plus x plus 1/2 to the 4 square dx. You see that? This is like integral of 1 over 1 plus u square times, that is u prime, right? So in that case, as the formula said, in that case basically, so if you do the integral of the right side, this is like integral of that and integral of that. If you do that, integral and derivative cancel, that will be tangent inverse u. So what is the u then? The final answer is 1/4 tangent inverse x plus 1/2 over 4 plus c. That is the final answer. If you want to simplify that, you could write the same denominator there. So 2x plus 1 over 8. You can write like that. This one you can write 2x plus 1 over 8 as well if you want to. Okay guys, so that's how we do question number 45. So next time we will do a couple more examples from this same section. Okay, so from this video what you learned is there is no separate formula to do the problem on this section. This is the review of all the formula that you learned so far. Okay guys, all right, thank you very much.